Hello class, in this video I would like to review the operations with a Taylor series. So depending on what we have, if we have two functions being represented by a Taylor series, in this case f of x and g of x, f of x having coefficients a sub 0 through a sub n, and g of x having coefficients b sub 0 through b sub n, we could add the two Taylor series by adding those coefficients. So a sub 0 plus b sub 0, a sub 1 plus b sub 1 times x, a sub 2 plus b sub 2 times x squared, and so on. For all x in the interval of convergence of both f and g. So what this just means in nicer language, convergent series are added term by term. A second operation is for any real number c, the Taylor series for c times f of x will just be multiplying each individual term by c. For all x in the interval of convergence of f, and for any positive integer k, the Taylor series for k to the add x to the k power times f of x. So multiplying, that would just accomplish multiplying each term by x to the k power, and by doing so, since that Taylor series already had x to whatever power each term, would be adding exponents, right? So a sub 0 times x to the k plus a sub 1 times x to the k plus 1 plus a sub 2 times x to the k plus 2 all the way down to a sub n times x to the k plus n. And this is for all x in the interval of convergence of f. So I have two examples here, right? F of x is equal to 5 times e to the x. What we saw before, right, and this is in the previous video, but we saw before that the Taylor series for this was 1 plus x plus 1 over 2 factorial times x squared plus 1 over 3 factorial times x cubed, and this continued on down until 1 over n factorial times x to the nth power. But since we're multiplying e to the x here by 5, we can multiply each of those terms that I just wrote out by 5 and get our Taylor series for this one. So this one's going to be 5 plus 5x plus 5 over 2 factorial times x squared plus 5 over 3 factorial times x cubed, and so on, until we get down to 5 over n factorial times x to the nth power. And this is for all x in our interval of convergence of negative infinity to infinity. So that didn't change for this. For the second one I have on here, x cubed times the natural log of 1 plus x. So again, previous video for this one, we had our Taylor series for this one for just the natural log of 1 plus x. That for this was x minus a half x squared plus a third x cubed minus a fourth x to the fourth, and that kept alternating, right? So the nth term for this was negative 1 to the nth power times x to the n plus 1 divided by n plus 1. So multiplying term by term by this x cubed, this is going to make x cubed times x minus x cubed times 1/2 x squared plus x cubed times 1/3 x cubed minus x cubed times 1/4 x to the 4th. And again, that keeps going on. The nth term for this would be x cubed times -1 to the nth power times x to the n plus 1, all divided by n plus 1. And that keeps going on after that. So simplifying this slightly, this makes x to the 4th minus 1/2 x to the 5th plus 1/3 x to the 6th minus 1/4 x to the 7th. This keeps on going. The nth term is -1 to the nth power times x to the 4 plus n, all divided by n plus 1. Again, this keeps going on after that. Let me know if you have any questions or concerns. Thank you.